In this session, we will look at data mining and how it is used as a tool in research. At the end of this session, you will be able to investigate data mining and compare data mining models. Data mining methods have been developed over time using research. As data mining evolves, we have not only become able to navigate our data in real time, but have also progressed beyond mere access to retrospective data with navigational improvements. Using data warehousing and decision support, we could, for example, answer the question, what was the most commonly diagnosed disease in our 9-hospital system last April? We could then drill down to one hospital. As we have developed big data collection capabilities, data capture, data transmission, storage capabilities, powerful computers, statistics, artificial intelligence, high-functioning relational database engines with data integration, and advanced algorithms, we have realized the ability to data mine our big data to predict and deliver prospective and proactive information. We can begin to predict by answering a question such as, what is likely to be the most commonly diagnosed disease next month and why? Data mining includes tools for visualizing relationships in data and mechanizes the process of discovering predictive information in massive databases. Data mining is a repetitive, process that explores and models big data to identify patterns and provide meaningful insights. As we evolve, the tools with which we can collect, access, and process data and information is necessary to concomitantly evolve how we analyze and interpret the data and information. Data mining projects help organizations discover interesting knowledge. These projects can be predictive, exploratory, or focused on data reduction. Data mining focuses on producing a solution that generates useful forecasting through a 4-phase process. 1, problem identification. 2, exploration of data. 3, pattern discovery. And 4, knowledge deployment, or application of knowledge to new data to forecast or generate predictions. Data mining is an analytic, logical process that with the ultimate goal of forecasting or predicting. It mines or unearths concealed predictive information, constructing a picture or view of the data that lends insight into future trends, actions, and behaviors. This data exploration and resulting knowledge discovery fosters a proactive, knowledge-driven decision-making. Problem identification is the initial phase of data mining. The problem must be defined and everyone involved must understand the objectives and requirements of the data mining process they are initiating. Exploration begins with exploring and preparing the data for data mining process. This phase might include data access, cleansing, sampling, and transformation. Based on the problem you are trying to solve, data might need to be transformed into another format. To assure meaningful data mining outcomes, you must comprehend and truly understand your data. The goal of this phase is to identify the relevant or important variables and determine their nature. Sometimes known as model building or pattern identification, pattern discovery is a complex phase of data mining. In this phase, different models are applied to the same data to choose the best model for the data set being analyzed. It is imperative that the model chosen should identify the patterns in the data that will support the best predictions. The model must be tested, evaluated, and interpreted. Therefore, this phase ends with a highly predictive, consistent pattern identifying model. The final phase, knowledge deployment, takes the pattern and model identified in the pattern discovery phase and applies them to new data to test whether they can achieve the desired outcome. In this phase, the model achieves insight by following the rules of a decision tree to generate predictions or estimates of the expected outcome. This deployment provides the organization with the actionable information and knowledge necessary to make strategic decisions in uncertain situations. Data mining is also known as knowledge discovery and data mining in data and knowledge discovery in databases. The term knowledge discovery is key as data mining looks at data from different vantage points, aspects, and perspectives and brings new insights into the data set. This analysis then sorts and categorizes the data and finally summarizes the relationships identified. In essence, then, data mining is the process of finding correlations or patterns among the data. Healthcare, as noted earlier, generates big data. Data mining tools, in turn, are able to analyze enormous databases to determine patterns and establish applications to new data. Healthcare organizations clearly need to invest more in big data and data mining analysis. The big data market reached an estimated $2.2 billion in 2011, but only 6% of that investment came from healthcare. The healthcare sector has discovered data mining through the realization that knowledge discovery can help to improve healthcare policymaking, healthcare practices, disease prevention, detection of disease outbreaks, prevention of sequelae, and prevention of in-hospital deaths. On the business side, healthcare organizations can use data mining for the detection of falsified or fraudulent insurance claims. Over the last several decades, the knowledge discovery data capability has improved as the analytical power of data mining tools has increased, thereby facilitating the recognition of patterns and relationships in big data. The literature described how faculty used data mining to analyze students' clinical logs, which enabled them to make programmatic decisions and revisions and rethink certain clinical placements. Zupan and Demthar in 2008 described the open source tools developed by data mining researchers that they felt were ready to be used in biomedical research. Fernandez et al. In 2011 described workflow mining technology as a means to facilitate relearning in dementia processes. Lee et al. In 2011 discussed the application of data mining to identify critical factors such as nursing interventions related to patient fall outcomes. Lee, Lin, Mills, and Cow in 2012 used data mining to determine risk factors related to each stage of pressure ulcers and identified 5 predictive factors: hemoglobin level, weight, sex, height, and use of a repositioning sheet. Based on the results of this data mining analysis, nurses can better target their interventions to prevent pressure ulcers. Green et al. In 2013 identified differences in limb volume patterns in breast cancer survivors. Their results have the potential to influence clinical guidelines for the assessment of latent and early onset lymphedema. As these examples suggest, we must continue to employ data mining to reduce inefficiencies, improve quality, and support transformations using data-driven models of care. Data mining concepts include the following: bagging, which is a term for the use of voting and averaging in a predictive data mining to synthesize the predictions from many models or methods, or the use of the same type of model on different data. This term can also refer to the unpredictability of results when complex models are used to mine small data sets. Boosting is what the term infers, a means of increasing the power of the models generated by weighting the combinations of predictions from those models into a predicted classification. This repetitive process uses voting or averaging to combine the different classifiers. Data reduction shrinks large data into manageable smaller data sets. One way to accomplish this is via aggregation of the data or clustering. Drill down analysis typically begins by identifying variables of interest to drill down into the data. You could identify a diagnosis and drill down, for example, to determine the ages of those diagnosed or the number of males. You could then continue to drill down and expose even more data. Exploratory data analysis, or EDA, is an approach or philosophy that uses mainly graphical techniques to gain insight into a data set. Its goals vary based on the purpose of the analysis, but EDA can be applied to the data set to extract variables, detect outliers, and identify patterns. Feature selection reduces inputs into a manageable size for processing and analysis, as the model either chooses or rejects an attribute based on its usefulness for analysis. Feature selection reduces inputs to a manageable size for processing and analysis, as the model either chooses or rejects an attribute based on its usefulness for analysis. Machine learning is a subset of artificial intelligence that permits computers to learn either inductively or deductively. Inductive machine learning is the process of reasoning and making generalizations or extracting patterns and rules from huge data sets. That is, reasoning from a large number of examples to a general rule. Deductive machine learning moves from premises that are assumed true to conclusions that must be true if the premises are true. Meta-learning combines the predictions from several models. It is helpful when several different models are used in the same project. The predictions from the different classifiers or models can be included as input into meta-learning. The goal is to synthesize these predicted classifications to generate a final best predicted classification, a process also referred to as stacking. Predictive data mining identifies the data mining project as one with the goal of identifying a model that can predict classifications. And stacking, or stack generalization, synthesizes the predictions from several models. It is important to understand your data before you begin the data mining process so that you can choose the best technique and get the most from data mining. The commonly used techniques in data mining are neural networks, decision trees, rule induction, algorithms, and the nearest neighbor method. Neural networks represent nonlinear predictive models. These models learn through training and resemble the structure of the biological neural networks. That is, they model the neural behavior of the brain in humans. Computers are fast and can respond to instructions or programs repeatedly. Humans use their experience to generalize the world around them. Neural networks are a way to bridge the gap between computers and humans. Neural networks go through a learning process or training on existing data so that they can predict, recognize patterns, associate data, and classify data. Decision trees are so named because the sets of decisions form a tree-shaped structure. The decisions generate rules for classifying a data set. Classification and regression trees, or CART, and chi-square automatic interaction detection, or CHAID, are two commonly used types of decision tree methodologies. Rule induction is based on statistical significance. Rules are extracted from the data using if-then statements which become the rules. Algorithms are typically computer-based recipes or methods with which data mining models are developed. To create the model, the data set is first analyzed by the algorithm, looking for specific patterns and trends. Based on the results of this analysis, the algorithm defines the parameters of the data mining model. The identified parameters are then applied to the entire data set to mine it for patterns and statistics. Nearest neighbor analysis classifies each record in a data set based on a select number of its nearest neighbors. This technique is sometimes known as the k-nearest neighbor. Text mining is for text is equivalent to data mining for numerical data. Because text is not always consistent in healthcare owing to the lack of a generally accepted terminology structure, it is more difficult to analyze. Text documents are analyzed by extracting keywords or phrases. Online analytic processing generates different views of the data in multi-dimensional databases. These perspectives range from simplistic views such as descriptive statistics, frequency tables, or comparative summaries to more complicated analyses requiring various forms of cleansing the data such as removing outliers. Online analytic processing is also known as fast analysis of shared data. Brushing is a technique in which the user manually chooses specific data points or observations or subsets of data on an interactive data display. These selected data can be visualized in two-dimensional or three-dimensional surfaces as scatter plots. Brushing is also known as geographical exploratory data analysis. To generate predictions and infer relationships, the data set, statistics, and patterns identified in existing data must be applied to new data. A data mining model is developed by exercising more than algorithms on data. Specifically, the data mining model consists of mining structure plus an algorithm. The data mining model remains empty until it applies the algorithm or processes and analyzes the data provided by the mining structure. This model stores the information obtained from a statistical analysis of the data, identifying patterns and gaining insight. It then contains metadata that specify the name and definition of the model, the server location, or place where it is stored, definitions of any filters applied when processing the model, and the algorithm used to analyze the data. The columns, their data types, any filters, and the algorithm used are all choices that are made in the data mining process, and each of these decisions can greatly influence the data mining results. The same data can be used to create many models. One type of model could organize the data into trees, for example, where another type of model might cluster the data into groups based on the rules applied. Different results can be achieved from the same mining structure, even though it is used in many models, based on the filtering method or analysis conducted. Therefore, each decision made along the way is very important. There are many models, including these following models: cross-industry standard process for data mining, Six Sigma, and SEMA models. Let's look at each of these individually. The cross-industry standard process for data mining, or the CRISDN model, follows a path or series of steps to develop a business understanding by gaining an understanding of the business data collected and analyzed. The 6 steps are business understanding, data preparation, modeling, evaluation, and deployment. Modeling involves selection of the modeling methods and their application to the prepared data set. Parameters are calibrated, a test design is generated, and the model is built and assessed. This step might require you to revisit data preparation if the format of the data does not meet the specific requirements of the methods. Six Sigma is a data-driven method to eliminate defects, avoid waste, or assess quality control issues. It aims to decrease discrepancies in business and manufacturing processes through dedicated improvements. Six Sigma uses the DAMAC steps: define, measure, analyze, improve, and control. The acronym SEMA, sample, explore, modify, model, assess, refers to the core process of conducting data mining. This model is similar to Six Sigma, but concentrates more on the technical activities characteristically involved in data mining. Data mining in healthcare is dependent on the use of private health information. Practitioners engaging in data mining must ensure that such data are de-identified and that confidentiality is maintained. Because most data mining depends on the aggregation of data, maintaining individual patient confidentiality should be relatively straightforward. Big data is everywhere. We collect and store data every second of the day. Therefore, in healthcare, it is imperative that we use the knowledge discovery data to analyze these data sets and discover meaningful information that will influence our practice. Our existing data repositories are ripe for the picking. They contain hidden patterns, trends, and undiscovered nuggets that we must mine to continue to hone our understanding and improve healthcare. Data management is essential so that this process can begin with clean, good data. The decisions that are made when conducting the analysis and when developing the model and algorithms enables us to predict and discover patterns and trends in data, thereby making them meaningful. We must be able to not only extract meaningful information and knowledge, but also to share and disseminate what we are learning and the new knowledge that we are generating.